is working as a leader in educational sector since 1960 by providing social, scientific, and technical approach to students. Courses we offer are MTech, BTech, Diploma, Management, NSDC, Agriculture, MLS, HMCT, B Vocational, Fashion Designing, and many more. Our Computer Science, Engineering and IT department works with emergence of new technologies like multi-core processor, mobile and cloud computing. One of the oldest engineering are civil and mechanical engineering, which deals with the design, construction and maintenance of man-made structures and machines. Electronic communication engineering having solid background in device circuits, analog and digital machines. On the other hand, NSDC act as catalyst in skill providing skill training. Computer application deals with graphic designing and various computing languages, whereas MLS majorly focus on healthcare professional concerned with diagnosis, treatment and prevention of disease. Management and Agriculture department provides practical approach to help the farming community with the aim to boost agriculture growth in eco-friendly environment. Fashion designing, hotel management, and applied science department are the highly paid industries in today's world. Golden Group introduced vocational courses which are totally unique and innovative in the entire region, which provides certification in Asia. These courses are specifically for abroad-going students. Golden Group has vibrant training and placement cell. Our placement cell signed MOUs with various national and multinational companies for better placement of students. Golden Group organizes cultural and sports enjoyment, but most important to gain and improve skills. We have highly trained and qualified faculty in the entire region, which focus on overall growth of your child. Our motto is to make your dreams come true. Be the part of Golden family today. Golden Group is working as a leader in educational sector since 1960 by providing social, scientific, and technical approach to students. Courses we offer are MTech, BTech, Diploma, Management, NSDC, Agriculture, MLS, HM City, B Vocational, Fashion Designing, and many more. Our computer science, engineering and IT department works with emergence of new technologies like multi-core processor, mobile and cloud computing. One of the oldest engineering are civil and mechanical engineering, which deals with the design, construction and maintenance of man-made structures and machines. Electronic communication engineering having solid background in devices and circuits, analog and digital machines. On the other hand, NSDC act as catalyst in skill development by providing skill training. Computer application deals with graphic designing and various computing languages, whereas MLS majorly focus on healthcare professional concerned with diagnosis, treatment and prevention of disease. Management and Agriculture Department provides practical approach to help the farming community with the aim to boost agriculture growth in eco-friendly environment. Fashion Designing, Hotel Management and Applied Science Department are the highly paid industries in today's world. Golden Group introduced bivocational courses which are totally unique and innovative in the entire region, which provides certification in Asia. These courses are specifically for abroad-going students. Golden Group has vibrant training and placement cell. Our placement cell signed MOUs with various national and multinational companies for better placement of students. Golden Group organizes cultural and sports events to provide not only entertainment and enjoyment, but most important to gain and improve skills. We have highly trained and qualified faculty in the entire region, which focus on overall growth of your child. Our motto is to make your dreams come true.
Yeah, good morning, everyone. Thank you for having so much patience as we were waiting for the maximum participants to join for today's session. Again, good morning. My name is Engineer Suraj and I'm serving as the head of department in the Computer Science and Engineering Department of Golden College of Engineering and Technology, Gurdaspur. I, on the behalf of worthy management of entire Golden Group of Institutions, especially mentioning Dr. Mohit Mahajanji, Chairman, Golden Group of Institution, Engineer Raghav Mahajanji, Managing Director, Golden Group of Institutions, Dr. Lakwinder Pal Singh Ji, Principal, Golden College of Engineering and Technology, Gurdaspur, Engineer Mohinder Kumar Ji, Registrar, Golden Group of Institution. I welcome all the participants for today's webinar entitled as Project Management, and that includes all the principals, teachers, faculty members, and my dear students. Golden Group of Institutions Gurdaspur is comprised of multiple sub-institutions that includes Golden College of Engineering and Technology Gurdaspur, Golden Institute of Management and Technology Gurdaspur, Golden Polytechnic College, Golden College of Education, Golden Senior Secondary School, and Sri Nagli Academic Public School. Embarking the 60-year legacy of providing the quality education to the entire society, Golden Group has never remained behind in serving the society through numerous parameters. That includes either the providing of artificial limb donations to the various needy people or numerous blood donation camps, either the ration distribution or any kind of service that could help the poor and needy people to come across the country. Now, I would like to welcome our worthy key spokesperson for today's webinar, Dr.Swaresh Swarup, former Deputy Director, General Ministry of Commerce and Industry, Government of India. Although, sir, there are no such words that could describe or interpret your profile and designation, sir, but yet I would like to enlighten some of the key parameters. His cadre is Central Engineering Services, and he is an engineer by basic qualification, and he holds a master diploma in public administration along with the PhD in foreign trade from University of California. He has worked in India and abroad on prestigious senior level positions and has the techno-economic experience of 35 years. His area of expertise is project management, and he has visited the world-renowned Hoover Dam project, which is one of the key examples of project management these days. And he has also studied the various construction-related documents, focusing on the various management tools. Years ago, he has constructed one of the most difficult projects in India, Farakka Barrage project in the state of West Bengal. He is having a bulk of publications that includes various multinational conferences, expert talks on the issues of nuclear power plant in India, industrial growth, thermal welding of rails, and many more. It's a matter of pride for every single individual residing in India, and especially for all the single participant associated with entire Golden Group of Institutions Gurdaspur to have you as our key spokesperson, sir. Now, without wasting any time, I would like to invite our worthy Managing Director of Golden Group of Institutions, Engineer Raghav Mahajanji, to kindly welcome our personified key spokesperson for today's webinar. Over to you, Raghav, sir.
Am I audible?
Yes, sir, completely audible.
Respected Chairman, sir, principals, teachers, Dr.Swaresh Swarup, sir, and all the participants and students, a very good morning to all of you. Today, I'm glad that Golden Group of Institutions is going to organize a webinar on project management by one of the eminent personalities in the industry, Dr. Swaresh Swarup ji, Deputy Director General, former Deputy Director General, Ministry of Commerce and Industry, Government of India. Sir has a great experience and they have worked on live projects. So I hope all the students and all the participants can listen and learn a lot of things from your experience and live projects. I, Raghav Mahajan, on behalf of whole Golden Group of Institutions, welcomes you for this webinar, sir. Thank you so much.
Thank you so much, sir. Okay, now I would like to request all the participants to maintain their discipline and decorum for today's session. And I request all the participants to put your keen observation throughout the session, as we are going to get the abundance of knowledge from today's key spokesperson today, sir. So without wasting any time, I would like to invite our spokesperson for today's webinar to continue his session and share his valuable thoughts with all of us, every participant of entire Golden Group of Institutions. Thank you, sir. Thank you so much. You can continue your session, sir.
Good morning, respected Dr. Mohit Mahachanji, Chairman, sir, Mr. Raghav Mahachan, Mr. Mohit Mahachan, respected faculty, and dear students of Golden Group of Institutions, Gurdaspur. It is my proud privilege to get associated this morning with this esteemed institution, which is doing so well in the field of technical education. I have heard a lot and I have read a lot about the quality of education, the standards which Golden Group of Institutions, Gurdaspur, is maintaining. And I'm extremely happy to say that you are one of the best technical institutes in the country and maybe comparable with other institutes all over the world. It is my proud privilege to be associated this morning with this institute of great eminence and who have given me the opportunity to share the knowledge. I have few humble submissions to make. One, the presentation that I have made on the Hoover Dam is unique, and what instigated me to make this presentation is that more than 75 years ago, the Americans were so advanced that they constructed this project without any time and cost overruns and reduced the construction time from 7 years to 5 years. More than 75 years old. Friends, I will punctuate my presentation in between. A, with the project that I constructed as a young engineer in India for a Kabiraj, and the other projects which I have handled as Director World Bank. And I would be able to figure out what has gone wrong. Not that we are not an enterprising country, But the statement of fact is that in India, most of the projects we have tremendous time and cost overruns. Whereas the Americans were so advanced that there was no time and cost overrun, and they could reduce the time, and there were no computers. So what kind of methods they improvised to monitor the progress and reduce the time? I'll talk it. This is what I have covered in my presentation. So my humble request is, please watch my presentation, listen to me carefully, and it will be a major value addition in your knowledge base as an engineer or as a management executive. Point number two, in a project, a project manager will be an efficient project manager provided A, he understands the technicalities of the project well, B, he also understands the management tools which are to be used. Friends, management tools are not written anywhere. Management tools are to be improvised, system oriented, project oriented. Therefore, in short, if you have to be an efficient project manager, you have to be perfect as an MBA about the technicalities of the project, or as an engineer about the management tools to be used in the project. So this is the focus area of my presentation, that I have been able to identify the management tools used in the construction of Hoover Dam project by the American engineers more than 75 years ago. And they were so perfect that they could reduce the time from 7 years to 5 years. I will briefly go through first with the principles of project management, because the topic is project management. So I thought before I come to the major presentation, I will go through the principles of project management. Then I will give you the topography of the region where the Hoover Dam stands constructed and what were the problem. Then come to the presentation. After I finish the presentation, I have an audio visual given to me by the project authorities showing the construction of the project under the most arduous working conditions. Very, very interesting. Very, very interesting and knowledgeable. So in short, this presentation is going to be a major value addition in the knowledge base of your technical students and management students. Principles of project management are basically inventory and warehouse management, proper sequencing of construction processes, purchase and contract management, budget management, manpower management, resource management, develop effective project management tools, templates, virtually map out the projects, keep an eye on the progress, work together more efficiently, plan, track, and collaborate with the project management software, timeline integrations, project lifecycle curves, supply chain management. These are the basic principles of management. Friends, before I start my presentation, let me give you the topography. United States is a big continent, East Coast and West Coast. East Coast is New York. West Coast has 7 states: California, Colorado, Nevada, Arizona, Utah, Wyoming, New Mexico, and California. The economy of the West was in a very bad shape because this Colorado River, which originates from Colorado Mountains, travels dangerously through the Grand Canyons, which are rocks of volcanic origin called andesite breccia. And the Americans tried and tried very hard to harness, capture this river, but nobody could succeed for at least half a century. And many people died who tried to do something, because these Grand Canyons are dangerous terrains yet not fully explored. And the river changes its course, one, and the river has steep gradients as high as 72 feet. Therefore, how to control this river? Two, the topography is such that from the Colorado Mountains it comes to Grand Canyons, and immediately after coming out from the Grand Canyons, it enters the desert states of Nevada and Arizona. Believe me, that the desert used to get flooded by this river because it changes its course. The embankments which they were making, spending billions and billions of dollars, were all going waste, and the Americans' economy was in a very bad shape. There was no development in the west coast. B. The nature was also not kind. Arid, arid zone. The river flows through the arid and semi-arid zones. Arid zone is one where rainfall in a year is maximum up to 10 inches. Semi-arid zones are those where the rainfall in a year is between 10 inch to 20 inches, which is nothing. So the river was uncontrollable. B, rainfall was not adequate. Therefore, drinking water was not there, industry was not there, agriculture was not there. Hence, no development. That is how Mr. Herbert Hoover himself was an engineer. That time he was Secretary of State in the US government. And he conceptualized this project, gave the task to the Bureau of Reclamation that you work out a project, a dam to be constructed to harness this river. My dear friends, the Americans took 50 years, 1857 to 1931, more than 50 years to conceptualize and work on the project. And once the project design was completed, no changes were undertaken, and they completed the project instead of 7 years to 5 years. That was the reason to work out or conceptualize the Hoover Dam project. I will now start the presentation, and then when I'm running through, I will punctuate in between and tell you the glaring examples of the projects which I constructed for Akabraj, which I handled, what has gone wrong. And we know that the things are going wrong, but still we do not take corrective steps. But Americans, no, nothing went wrong, and everything was smooth. But there were no computers, no softwares, but they still controlled so methodically that the time was reduced from 7 years to 5 years. Am I clear up to this point? Okay. Now I'm starting with my presentation. Please. Mix up. Mix up.
Yeah.
It's not changing. Thank you. Topography and history, conceptualization of the project, project design, project management, project implementation, project benefits. The construction was conceptualized during the recession by using efficient personnel, innovative techniques, the finest equipment of the time, and detailed planning to achieve flood control, river regulation, improvement of navigation, storage of water for irrigation, drinking water supply, hydroelectric power generation. This is the overview of the Hoover Dam. Both sides, you can see the Grand Canyons. And at the back is Lake Mead. These four are intake towers, which are kind of filters. I'll explain in detail little later on. And from here, the penstocks pipe go inside and go up to the turbines. This is an overview of the dam. It's an arch type gravity dam. 1857, the first expedition was undertaken for, in a steamboat and proceeded upstream. Traveled a 400 miles before wrecking the boat on a submerged rock of the lower and block canyons. The width of the canyon being minimum at this point, the construction of the dam was visualized. The second expedition was undertaken by Major Powell years later in 1969 and covered the treacherous canyons downstream about 1,000 miles and saw the potential of the same site. The data collected was examined, analyzed, and through for about 39 years. This is the view where the dangerous terrain, Black Canyon, where the dam stands constructed now, 800 feet down gorge, where the river flows at a steep gradient. This is the terrain. You can see an overview. Now, Grand Canyons are the rocks of volcanic origin, geographically called andesite breccia. It is one of the hardest rock found. The whole area is still not explored, where the dam stands constructed, and the temperature variation is so great. I saw ice, even in the desert, there is a snowfall. Temperature is minus 30 degrees centigrade to plus 50 degrees centigrade. The site was very difficult, unapproachable, and all the tools were thought of, well thought of, and improvised much in advance before this construction started. Igneous metamorphic and sedimentary rocks. Red Indians who did the limited exploration work around 400 AD named the bottommost rock as Vishnu rock. The topmost layer of the rock is called the kebab. This is the location. Investigations revealed that Black Canyon is the ideal site in 1920. Now, please see from 1857, they have come to 1922. Representatives having the states met to reach an agreement resulting in the Colorado River Compact. In 1922, the Reclamation Service presented a report calling for the development of a dam on Colorado River. Now, this is the virgin site where the dam stands constructed now, called Black Canyon. The site of the project being large, no single company was found to be capable to handle the total project. In January 10, 1931, the Bureau of Reclamation made a bid document available to interested parties at $5 a copy. The government was to provide the materials, but the contractor was to prepare the site and build the dam. Friends, I am a man of contracts in the Government of India. I have handled Government of India procurement, domestic and international. Therefore, I must give a briefing about the contract management, which is one of the you know principles of project management. To be very brief, what is a contract? A contract is a bilateral agreement between two parties at the predefined terms and conditions. This is the basic definition. What it consists of? A contract consists of majorly three parts. One is specification, second is commercial terms and conditions, and the third is litigation. So technical specification is Indian standard specification, British standard specification, or API. Commercial terms are like terms of delivery, packing, okay? All these are consisting of commercial terms and conditions. Litigation means where do you go? Arbitrator, court. So these contracts are of two, three types. One is a simple supply contract that you buy and pay. Other is supply, erection, and commissioning contracts. Most of the project contracts are supply, erection, and commissioning contracts. Then others are import and export contracts. We have FOB contracts, free on board, FAS, free alongside ship, and FICIF, cost insurance freight contracts, where the freight is paid up to the seaport or where the freight is paid overseas port, like that. Most importantly, please learn today that if you go into a job and your you know employer asks you to prepare a global bid document, my dear friends, don't get lost. How you prepare a global bid document? In a global bid document, you cannot use Indian standard specification, you cannot use British standard specification, and you cannot use API. You have to use generic specification. And generic specification is the one that you have to generate by virtue of your technical knowledge. Therefore, MBA friends, engineer friends, learn to improvise generic specifications by virtue of studying the technical literature of a product which you are trying to import from the various manufacturers all over the world, and pick up the vital technical parameters. A power plant you want to import, you know what is the capacity of the plant, and you know what is the size of the plant that you want to install. Keeping these vital parameters, you generate your generic specification, and that is what you have to put in the bid document. This is the most important area in the global tendering, and this is the job which I have been doing for all kind of plant and machinery in the procurement. Friends, very, very important in the area of contract management. Now, in Hoover Dam, looking into the size of the project, no single company was in a position to fund it by itself. Therefore, it was the government of United States decision that they will keep it only erection and commissioning contract. Therefore, supply of equipment, supply of material, supply of technology was the responsibility of the government. What is a project? A project is an effective integration of five tools: man, machine, material, finance, and technology. All these have to be effectively integrated. So they decided to keep it only as an erection and commissioning contract. Therefore, we in a global tender, there are two things. A is bid money, which is a token money everyone has to give by in the favor of bank guarantee. The guy whose bid is accepted, he has to submit a performance guarantee bond, which is normally 10% of the value of the contract, and that is kept valid until the successful completion of the contract. These are the management tools or the in the area of purchase and contract management, which I thought I must share with you in this limited time that I have at my disposal. A 2 million bid bond was to company. Each bid, the winner would have to post a 5 million performance bond. The contractor had 7 years to build the dam, or penalties would issue. Now, this consortium was called Seven Seas. Six companies incorporated. They were the lowest, and they got the contract. So erection and commissioning contract at a price of 48,890,995 million dollars. Now, I said management tools. Management tools. A project manager has to be a system integrator. Your sixth sense has to tell you every day whatever we are doing in our life is a project where time is involved and money is involved. If we are conscious that what is to be brought at the site of where you are constructing a house. Now, if you are constructing a house at a cost of 30 lakhs of rupees, one room house you want to construct, at the back of your mind, you decide that I should complete the house in 3 months' time. This 3 months' time is the critical path. Should you exceed 3 months' time, you will pay more. This is one of the management tools. Then, this 3 months time you divide into segments. What is to be brought at site first, and then second and the third. Therefore, when the foundation is being dug, you will not bring cement at that time because cement has a short shelf life from the date of manufacturing. Should you do it, it will lose most of the life lying at the side. So I said sequencing is very important. What is to be brought at site at what point of time is very important, and that is where your knowledge is required. I started initially, I said, perfect in the technicalities of the project and looking into the technicalities of the project. At the back of your mind, you should keep improvising the management tools which are to be modified from time to time. Now, in the construction of a dam, either it is Bhakra Dam or any other dam, step one is the river is to be harnessed. So we make a sand coffer dam. Once you have made a sand coffer dam, then you divert the river through the tunnels. We did the same thing in Bhakra. When the Bhakra was under construction, I, as a school college student, I visited the Bhakra project, and we make two tunnels both sides, divert the water through the tunnels. Then we start making foundation, digging the foundation for the main dam or wall of the dam, you can say. After you have completed the dam wall, you demolish the Sankofa dam and close the tunnels. The water then is taken through the penstocks up to the turbine. These are the basic steps. So, Mr. Herbert Hoover, as I said, was Secretary of State in the US government as an engineer. He was the one who conceptualized this project, and they said till the time the tunnel work is completed, the main project cannot start. Therefore, they imposed a penalty of $3,000 per day for 1 day delay in the construction of the tunnels. The, the flyovers which we are constructing in India, the contract, the contract is a work contract, and you may be aware that funding part. One is simple loan, the other is credit line, third is debt relief grant. All the flyovers which we have are World Bank funded projects, 100 lakhs. So there's a clause that if you complete it on time, you get additional 10 lakhs of rupees, 110 lakhs. And if you delay it by 1 day, 10 lakhs rupees per day penalty. So they improvise this $3,000 per day penalty for 1 day delay to ensure that the tunnel work was completed on time. I'll tell you a little later that there are four tunnels, two on each side, 50 feet diameter, line tunnels, 3 miles long each, which can carry 200,000 cusecs of water per second. This was management tool one. Work began in March 1931, programmed for 7 years, but completed ahead of schedule in 5 years. Effective management tools used. System integration was followed. Now, this is the project life cycle. Very, very important cycle curve of a project. The project that you are dealing with, you should divide it into these four parts. On the y-axis, we have level of effort. On the x-axis, we have the time. I said 3 months time, or 7 months time, or 7 years time. The percentage is approximately 4% of the effort is put in the conceptualization of the project. 8% of the effort is put in the development of the project, and 85% of the effort is put in the execution of the project, and 3% in the winding up the project. And under conceptualization, these are the areas you can go through these: development, feasibility, procurement, tools, execution, planning, scheduling, technical requirements, detailed procurement, making the plant and machinery available at site. So project life cycle curve has to be drawn subject to modification from time to time. This is one of the important principles of project management. The managers were fully conversant with the topography of the region. They had specialization in design and construction techniques The PM project management techniques were applied through system approach. Therefore, the project managers were perfect system integrators. Concept of a project, categories of projects, project life cycle phases, project management concepts, tools and techniques of project management, project management managers' role and responsibilities, project management education. These are the statistics of the dam. It is the highest in the world, 726.4 feet from the bedrock, and as high as a 72-story building. Weighs 66 lakh tons, base width 660 feet, top width 45 feet. Then power plant has so much cubic yards of concrete was used. Total 43.50 lakhs of cubic yards of concrete were used. Water pressure, the maximum pressure at the base of the dam is 45,000 pounds per square feet. Manpower deployed was about 3,500 workers. Friends, please see this picture. Initially, you saw these intake towers as submerged. These are the filters. These are the filters, and then you can see the arch type dam fully constructed. But the Sankofa Dam has yet not been demolished. That's why you are seeing these structures, intake towers. These are the filters through which a 30 feet diameter penstock pipe carries the water up to the smaller diameter pipes and up to the turbines. Construction of four intake towers, two on each side. Diameter of these towers is 82 feet at the base and 62.3 feet at the top. Each tower is 395 feet high and controls one-fourth supply of water for the power plant. Penstock pipes made of 3 inches, steel pipe plate, length 2.75 miles, weighing more than 44,000 tons. A plate steel fabricating plant was set up at this time. The dam design was finalized as gravity type arch dam. Cooling water plant for curing of concrete. Now, I said management tools, and I also said the site was very difficult, unapproachable, desert, minus 30 degrees temperature in the desert to 50 degrees temperature. Therefore, management tools were basically penalty $3,000 per day. Then the plants at site. Batching plant is one, cooling water plant is two, drinking water plant is three, welding plant is fourth. These are the major tools which were thought of and made in position on time before the construction started. Then a complete township, free medical, free housing, all these facilities were created. Only then the people went there to live and started working on the project. Shear weight of concrete holds the river back, while arch transfer the load or weight of the concrete into the rock walls of the Black Canyons. This is an arch type dam. So through the arch, the load is transferred through the walls of the canyon. It is such a perfect integration that you feel as if the concrete and arch they are the same. There is no difference. It's such a perfect integration between the concrete wall and the canyon walls. The unusual feature was that the dam was built in blocks or vertical columns. Now I'm coming to a very important area, curing. Friends, curing is, when the concrete settles, it emanates chemical heat. And if chemical heat is not properly drenched, it can create cracks. That's why when you construct a house, on the roof, on the roof, you sprinkle water. That is enough. What is the temperature of that water? 5 to 7 degrees centigrade. Here, but that is not perfect curing. That is not perfect curing. Technically, I'm talking. Perfect curing is when the water temperature is almost 0 degree centigrade. Therefore, They set up a plant, cooling water plant at site, which will supply water at zero point 0.5 degrees centigrade. And that water was circulated through capillary tubes, 1 inch diameter, total length 600 miles, through the blocks, because dam is constructed through the blocks. And once the construction was completed, concrete was filled into these capillaries. That is how the curing was complete. And even today, when they are drawing samples of concrete, it is gaining strength day in and day out. Now, I'll tell you a little later what happened in India and what happened in Delhi and what happened in Faraka, the project that I constructed. Disputes regarding the water and power sharing cropped up amongst the states which were located in the upper and lower basins of the river. The states involved were Wyoming, Arizona, Nevada, New Mexico, Utah, California, and Colorado. The Colorado River Compact legislation that preceded the building of the dam authorized 7 states to work together to decide how to appropriate shared waters. Friends, let me tell you about Faraka Barrage that I constructed. Most of the people may not know that the river Hooghly has no original source of water. River Hooghly's original source of water is Bhagirathi, which is a tributary of Ganges, and that got dried up, came at a higher level, so there is no original source of water. And as on date, what is coming in the Hooghly River is only the backwash from the sea. Therefore, Hooghly is not fully navigable. Ships of higher tonnage do not come up to Calcutta port, and Calcutta is yet not a port. Therefore, we conceptualized the Fracka barrage, making a barrage, rail and road bridge, which connects the northeast. And by making the barrage, we made a feeder canal, and through the feeder canal, we put additional water into the river Hooghly, which keeps it going. That is how we conceptualize the Faraka barrage. Now, I'm using the word conceptualization of the project is very important. Conceptualization of the Faraka barrage was totally wrong because at that time it was East Pakistan. We were not in good terms. And Faraka barrage is 8 miles upstream of East Pakistan. We lost a lot of equipment by way of sabotage, and the safety and security was all the time in danger. Through rafts and all that, when you are crossing the river, if you drift 8 miles downstream, you are a prisoner of war in East Pakistan. So Faraka was a difficult project. Technically, what went wrong? When you design a bridge, you design the pillars, we call rafts, and you design the rafts looking into the thrust of water that comes on the pillars. You calculate the raft thickness according to the water pressure. Well, top engineers of the country designed the Faraka Barrage, K. Rao, Nanjan Daya, and all that. And they designed the raft thickness as 10 feet. Good. I was a young engineer, mechanical engineer, given the charge of construction and operating the machines in the field. I started constructing from the left bank, constructed a Sandcoffer dam, and then first 10 pillars were 10 feet in thickness. Great. After that, the top engineers of the country thought that let us review the design. They reviewed the design and thought that no, the raft thickness can be reduced, and they decided to reduce it from 10 feet to 6 feet. Therefore, Faraka Barrage has 108 pillars. First 10, which I constructed, are 10 feet. 11 to 108 are 6 feet. Nobody would see now. Those pillars are under the water. But what happened? The cement, concrete, steel, labor, all 6 to 10 feet is a waste. Is a waste. That is how and Faraka Barrage cost went up vehemently. 400 crores project got completed in 20 years and 2,000 crores rupees. Therefore, I'll compare how perfect the engineers were. As I said repeatedly, I'm saying Herbert Hoover was an engineer, an architect of this project, and they improvised They improvise and use such mathematical formulas, which I will also talk about, that they could control the time and cost overruns. Okay, the construction work started. President Calvin Coolidge signed the Boulder Canyon project into law, approved the Colorado River Compact, and directed that the beneficiary state should ratify the compact. President proclamation was issued on June 25th, 1929, authorizing the construction of the dam and canal. Funds of so many 65 million were sanctioned. September 17th, 1930, Secretary of Interior issued a notification for construction in Black Canyon. The US Congress decided to name it as Hoover Dam. Now, bar charts, life cycle curves, line of balance, these are the tools to execute a project. I would be talking in bit detail about the PERD and CPM techniques which are used. The productivity budgeting techniques, total quality management, value engineering, cost breakdown structure. Friends, this is a symbolic PERD and CPM chart. Program evaluation review technique was applied in the construction of the project. This is used where the duration of various activities can not be predicted with certainty. PERD and CPM majorly helps in the calculation of total time of the construction of a project. The diagram symbolically represents circles as events and lines as activities. After every activity, there is an event. Therefore, in a project, not one, thousands of activities go on concurrently. Today, softwares are developed, as I said, in the principles, but in more than 75 years ago, there were no computers and no softwares. But the Americans were still so perfect that they could reduce the time, which we will talk in later how they did it. But symbolically or basically, circle represents an event, line represents an activity, and activity terminates at event and then proceeds further. So all activities are concurrently going together and finally converge at the last event. And the longest path is called the critical path. And this is what is to be monitored all the time when you are executing a project, that how you shorten the critical path. If you succeed to shorten the critical path, you are a perfect project manager. You understand the management tools and you understand the technicalities of the project pretty well. Otherwise, if you see that you are either close to critical path or you are about to exceed the critical path, there is something drastically wrong. You must relook. Relook what? Relook whether the activities have been properly identified, whether the activities are correct. Two, whether the activities are properly sequenced. Three, whether the activity time is rational. A, whether the activity is right. B, whether the activity has been properly sequenced. C, whether the activity time is realistic. These are the three most important things in the planning or execution of a PERT and activity time, calculating the activity time. Now, the longest path is called the critical path. Summation of total time should be less than the critical path. If the activity time wise has been calculated in a realistic manner, here lies the expertise of the project manager as a system integrator. As I said just now, that if you are continuously over a period of time when the project is proceeding, you are reducing the critical time, you are doing a good job. But if you are not able to do that, the whole project has to be re-evaluated. Everything has to be re-looked into. Activities have to be re-looked into and reframed and reset sequentially. Friends, this is the formula they were using. Activity time is calculated as TO is objective time, optimistic time, M is most likely time, P is the pessimistic time. What is optimistic time? Optimistic time is the one which is realistic time. A person who knows the project or who knows his job well and says, I'll be able to complete this job in 4 days' time. Realistic time, that is optimistic time. A person who does not want to take any risk and he says, no, I will not, I want to play safe, he is pessimistic and he will say, no, I will complete it in 10 days. The 4 days and 10 days. Now, M is most likely time. Most likely time can be the arithmetic mean of optimistic and pessimistic time, but may not be the arithmetic mean of optimistic and pessimistic time. May not be. Therefore, the whole expertise of a project manager lies in the calculation of activity time. What the standard deviation? Standard deviation is pessimistic minus optimistic divided by 6 is rho, rho, and value of tan theta, which is 1 at 45 degrees and 225 degrees. So they were using this formula to calculate the standard deviation in the activity time. This is the catch point, that standard deviation was not allowed from, it can be 1 maximum, it can be zero point 0.9, 0.8, 7, 8, 9, but wherever they will see that the standard deviation in the activity is going close to zero point 0.9, zero point 0.8, they will immediately review it and review A, whether the person deployed is right or no. Two, whether the activity is right or no. Whether the activity time is right or no. Person, activity, time, sequence. These are the four most important things one must take care. And if they find it is not correct, they may even delete the activity. So this is what is required to be done. Gentlemen and friends, the variation was not allowed in the standard deviation more than zero point 0.4, more than zero point 0.4. And that is how they reduce the time from 7 years to 5 years. Ideally, to keep the activity time and cost at bare minimum, the numerator should be bare minimum and the denominator should be maximum. Herbert Hoover, Secretary of Commerce, himself being an engineer and architect of the project, undertook several modifications of the formula. Friends, I am driving the point modifications on formula. Formula modification of the formula means you can increase the denominator. I studied the project, This presentation is unique because I have visited the project and have gone through the documents and I have seen that there is nothing like standard formula. In India, normally we dare not touch a formula. Formulas are not God gifted. I do not know who has improvised the formula. But they said you have the liberty to increase the denominator to reduce the activity time. Yes, I could see from 6 to 8, 8 to 12 in the denominator. Full liberty was given and they reduced the time. Therefore, the activity time was modified to optimistic plus 4m divided by 6. So most likely is most likely, optimistic is as minimum as possible, and pessimistic time was removed. I am repeatedly trying to drive this in the mind of young would-be project managers. Young would-be project managers that I am talking today. Please, you should also be so confident about yourself that you can modify the formula like this: optimistic plus 4m divided by 6. Or you can say optimistic plus 3m divided by 8. Nobody stops you to do that, but provided you have confidence in yourself. Okay, standard deviation as close to zero point 0.1 as possible. The ultimate objective was to keep the sigma TE less than CP. Sigma TE is the total time of all the activities, should be less than the critical path. Thus, critical path was the longest time, reduced from 7 years to 5 years. I just mentioned about the curing. Curing is heat, technical heat. Friends, You will be shocked when I talk to you about the Delhi Metro. A cantilever tower in Delhi near Mulchand Hospital collapsed when they were putting the beam on it. 4 or 5 people died. A committee was appointed to identify the reason, and they identified that the curing was not perfect. A crack was developing from inside. When the beam was kept, it emerged on the surface and the tower collapsed. Because, mind my words, Delhi Metro cooling or curing is done at normal water temperature, which is 78 degrees. Then they said they appointed a committee to study all the Delhi Metro towers. I have the report with me. 17 towers of the Delhi Metro have internal cracks. Metro is running because cooling is still done at 4 to 7 degrees temperature. Here, they set up a cooling water plant and water is supplied at zero point 0.5 degrees centigrade. Therefore, when you are dealing with a project where massive concrete work is done, you should, in your own capacity, say that please set up a cooling water plant at site so that we do the curing at zero point 0.5 degrees centigrade. That is how the Hoover Dam was, curing was done. Else it would have taken more than 100 years. This is very, very important, but nobody hears. The metro is being constructed all over all the cities in India, and you go and see that they are only spraying water from a tube at 6 to 7 degrees temperature, and this is what is happening. People would not know, and the metro is running in Delhi. That's all I would say safely, but at the grace of the God. Friends, these are the tunnels. Original footage of the tunnels: 50 feet diameter, each tunnel 3 miles long. And some people died because carbon monoxide emits when you do the digging, and no, there was no control. I mean, they were taking oxygen, but some casualties did take place. Construction of the 4 intake towers. Construction of main arch type gravity dam. The dam was built in blocks or vertical columns varying in size. Columns were locked together by a system of ridges or keys. Concrete placement in one block was limited to 5 feet in 72 hours. Lake Mead area, this is the lake which is at the back. 1,56,800 acres, square miles. Depth is 500 feet. Length of the dam is 1244 feet. Catchment area is 167,800 square miles. Reservoir length 112 miles. Hydraulic head 590 feet. Coordinates 360 degrees. Total irrigated area so much. There is another important thing, friends. I would like to share with you value engineering. Management tools I have been talking about. Value engineering is another important management tool which is used mostly in most of the projects. What is value engineering? Value engineering is nothing but review of the design and removal of the unwanted costs, thus reducing the overall cost of the project. That is value engineering. It is a ratio of function to cost. If you reduce the cost, I mean, if you want to reduce the cost, you have to reduce the function. The function to cost is ratio is called value engineering. Technically, value engineering is a review of the design of a project continuously, removing the unwanted areas so that the design becomes more, up to date and costs are reduced. Now, this is a simple thing, powerhouse thing. When water flows over the turbine blades under pressure, it creates a centrifugal force. Pressure energy is converted into velocity energy. Water is discharged at atmospheric pressure of 14.7 pounds per square inch. It creates a high velocity head, which is turned in rotation to the turbines. One cubic foot of water flowing down at a speed of 8.81 feet per second at 100% efficiency is 1 horsepower. 1 cubic foot of water flowing down at a speed of 8.81 feet per second at 100% efficiency is equal to 1 horsepower. Well, engineers would know what is hidden inside the water, but management students should see this picture. Generator is visible to you, but generator is coupled to a turbine, and when the water glides over the blades, the pressure energy is converted into kinetic energy and creates a centrifugal force which gives a rotation to the turbine blades. This is the picture. Turbines are of two types, pressure turbines and velocity turbines. The water is under pressure, the wheel must run full and may therefore be entirely submerged below the tail race. The entire Colorado River has been harnessed and flow through the penstocks of the turbines. Power plant has 17 main and 2 auxiliary Francis type of turbines. 17 turbines supply power to the grid. 2 auxiliary turbines. Installed capacity is 2080 megawatt. Even an earthquake of 7.2 cannot affect the Hoover Dam. The construction is such, withstand the impact of a bomb. During Second World War 45, the Nazis, German forces, they tried to bombard it, but they did not succeed. The process of learning never ends, and infinity is the limit of excellence. Friends, I will now switch over to an audio visual showing the actual construction of the project under the most arduous working conditions. And after about 20 minutes, we will take the question and answer sessions. Please watch the audio visual.
An American pyramid, a colossus of concrete across the raging Colorado.
Trucks, man, noise, thunder, dust, everything is just harsh, harsh, harsh.
It would forever change the West. Hoover Dam.
It has been called an American pyramid, a 60-story colossus of concrete, built in the middle of a desert every bit as brutal as in ancient Egypt.
Hoover Dam changed the history of the West.
Their challenge was to harness the country's wildest river, the mighty Colorado, to bring water, power, and people to the Southwest. Now, in a more environmentally conscious age, many wish Hoover Dam had never been built. Yet it stands as a monument to the ingenuity and the sheer human will that forever changed the face of America. The Colorado was a river unlike any other. Dark and red with mud and silt from carving out the planet's most magnificent canyons. It ran wild until 1901, when Western farmers set out to tame it. Their plan was to water the desert. Developers dug a canal system that brought the river west into Lower California and turned parched soil into a vast agricultural paradise they called the Imperial Valley. for 4 bountiful years, farmers thought they were living a miracle. Then, without warning, the river struck back. In 1905, the Colorado tore open the canal and flooded the valley, creating an inland sea across 150 square miles. Over the next 2 decades, floods would wipe out thousands of farmers. The 1,400-mile Colorado became the obsession of the U.S. Bureau of Reclamation, the agency charged with finding ways to irrigate the arid West. In 1920, the Bureau embarked on an ambitious plan to dam the Colorado and distribute its water hundreds of miles in every direction. It was called the Boulder Canyon Project. Survey crews were sent down the treacherous river to look for the best place to build what would be the largest dam in America.
One of the slogans for the river at that time was that it was too thick to drink and too thin to plow.
The battle to conquer the Colorado soon turned deadly. After 4 years of surveys and tests, Bureau engineers chose Black Canyon on the Arizona-Nevada border as the site for Boulder Dam. In 1922, Hoover negotiated an agreement among the 7 western states that shared rights to the water to be captured by the proposed dam. With a contract in hand, the project cleared its first big political hurdle. By the summer of 1930, the government had not yet hired a contractor to build the dam. But the Bureau did begin laying rail and phone lines from Las Vegas out to Black Canyon. Builders from around the country came to study Black Canyon. But whoever did the job would have to come up with a $5 million performance bond, a risk far beyond the means of any single construction company. In the West, a group of independent contractors formed a partnership they called 6 Companies.
But there was something beyond that. This was the biggest project that anybody had ever thought of.
A 6 Companies engineer admitted they were all scared stiff. The government's plan called for a massive concrete wedge over 700 feet high, twice as tall as the Statue of Liberty and 2 football fields wide at the bottom. Workers would have to build 2 power plants at the base and dig 4 long tunnels through hard canyon rock to divert the river around the work site. They would need to pour 4.5 million cubic yards of concrete, enough for a 2-lane road from Los Angeles to Boston, and build a city in the desert virtually overnight to house 5,000 workers and their families. In the beginning, there were no roads. Down at the bottom, there was no dry place to stand. To start the first and most dangerous phase of construction, the 4 diversion tunnels, 2 on each side of the river. Work crews would have to drill and blast 3/4 of a mile through the canyon walls to open the holes that would carry the river around the work site. 56 feet in diameter, they would then be lined with 3 feet of concrete.
Those diversion tunnels were unique. To get them lined up, the job of drilling and shooting with dynamite, removing the rock, it was logistically one of the toughest things they did in the dam.
6 Companies also had to contend with a rigid government deadline, 2.5 years to divert the river or face steep fines for every day they ran late. The volatile Colorado constantly threatened the job. In a flash, seasonal floods could wash away any plans for finishing on time. An almost comic contraption turned out to be Frank Crow's best weapon against the tunnel deadline. The steel and wood beast, called a drilling jumbo, carried 3 tiers of drills on a 10-ton truck. The rig was backed up to the face of the wall, and the 30 drills bored holes into the rock to plant dynamite. The jumbo could then be pulled away for blasting, and the whole operation moved to the next drilling area.
Million cubic yards of rock had to be moved. Drag lines, electric power shovels, trucks, men, dynamite, drills, noise, thunder, dust.
There were always cave-ins. There were always loose and sharp rocks falling about. You had men stumbling in areas that were not correctly lighted.
Frank Crow prowled the dam site day and night. To his men, he was both God and the devil, fair but intensely demanding. They gave him the nickname Hurry Up Crow.
The 6 company foremen, they were on me all the time. Keep the trucks moving, everybody moving.
That first summer, the 6 companies' payroll reached 1,400. The work never stopped. 3 shifts a day, every day.
You had to work 7.
Nevada law prohibited gasoline-powered trucks in the tunnels, but 6 companies, claiming the job was under federal jurisdiction, used them anyway. Carbon monoxide and dust choked the tunnels and silently poisoned the men inside. As the hellish year of 1931 turned to 1932, tensions eased when 6 companies finally moved workers and their families out of Ragtown and into Boulder City. It was a modern, model community, free of the liquor and gambling that was Las Vegas's stock in trade. Single men moved into large dormitories, while row upon row of 1-, 2-, and 3-room family cottages went up in a fury of sawdust and sand. The landscape changed so rapidly that it was common for a man to come home after his shift and walk into the wrong house. On the morning of November 13th, the nation's media converged on Black Canyon to witness the historic attempt to reroute the Colorado.
At 11:30 in the morning, a blast was put off down there near the entry in one of the big diversion tunnels. That was what put the show on the road.
Now they had to force the powerful Colorado to change direction. Throughout the day, workers furiously dumped tons of rock into the river's path, trying to build a barrier high enough and strong enough to push it back into the tunnels. By dawn, the battle was won. Man had moved the mighty Colorado from the bed it had known for 12 million years. The vast chasm seemed a slit through earth and time alike, wrote author Frank Waters. The rank smell of Mesozoic ooze and primeval muck filled the air. Down below grunted and growled. On June 6, 1933, after 2 years of preparation, workers finally poured the first bucket of concrete that would build the dam's famous face. Frank Crow now had 5,000 men working in a deep and narrow canyon. His main task, he said, was to keep them from accidentally killing each other. 65 had already lost their lives. It's poured concrete into blocks 5 feet deep that were stacked one on top of another in interlocking columns to form the dam structure. It was on the cliffs behind. 33 stories high, they would deliver water from the reservoir to the power plants under construction below.
There were things happening every second of every day down there. All the pieces of the jigsaw puzzle that had to be in place for this industrial construction to go on, it's just simply amazing.
115 miles long, 500 feet deep.
Dramatic. It looks like the hands of man holding back the canyon walls.
Inside the powerhouses hummed the engines of the American Southwest. 17 turbines generating more than 2 billion watts of electricity. Enough to supply 1.3 million people. The power plant's terrazzo floors recall the Native American heritage of the land. On September 30th, 1935, a crowd of 20,000 swarmed over what was being called the eighth wonder of the world. President Roosevelt came to dedicate the dam 2 years ahead of schedule.
I have the right once more to congratulate you who have builded Boulder Dam, and on behalf of the nation, to say to you, well done.
Hoover Dam heralded the beginning of the modern industrial West. Its electricity spurred unprecedented growth. Its flood control and irrigation created some of America's biggest farms and allowed them to flourish in the desert.
The audio is over now, and I would expect any questions, please.
Yeah, thank you so much, sir, for sharing your valuable and informative thoughts with all of us. I hope every participant must have extracted a bundle of facts regarding the project management, and especially those participants who are from engineering and management background, and they seek to work on the various constructional and management projects. As you have been one of the pride gems of our entire nation, sir, thereby looking after all the Indian students residing in the United States of America since 1 year. And this session will definitely act as an inspiration for all the participants and give a new direction to their entire professions. Now I would like to read one of the few queries or questions are there in the chat box. So I just read one of the fellows, he has asked the question that how the nearby habitat got affected by the construction of these such dams, and what are the prevention measures that we could take to avoid any adverse effects on the nearby habitat of the construction of such big dams.
See, any project does affect the habitat. There is no second thought about it. It affects the lifestyle of the people. It affects the nature. The forests are cut, the lands are acquired, the people are evacuated, and it affects the lifestyle of the people living over there. So any project will definitely affect the habitat of the people, and it is the government's responsibility to see and ensure that they are properly rehabilitated. But it does not happen all the time, and government completes the projects, but fact is the people do suffer later on because of the uh, migration or displacement or whatever you may say. So habitat definitely gets affected. I agree with the observation.
There is a second query, sir, that there is a myth I read somewhere on the internet that construction of this big size can also slow down the rotation of Earth. Is it possible or it is just a myth?
No, it's a myth. It's a myth, definitely. The construction of these big size projects is needed. It's call of the hour because of the size of population which is increasing. And if we do not construct such big power plants, in fact, in US itself, another project has been constructed in the West Coast, like Hoover Dam, because they were so short of power. And after that, only the West Coast has developed. So if you do not go for major plants, then the growth rate will be definitely affected. Gone are the days that we will go for small powerhouses feeding to smaller. Those concepts are there in India. That 10 will 10 it's 4 villages or 5 villages chosen. A small power plant is set up there. A small fall captured and a hydraulic power plant is set up. They generate say 10 megawatts or 5 megawatts of power, which is good enough for those local 200, 400 inhabitants and take care of that. But that is in a country like India. But to industrialize or to look for bigger agriculture and all that, we need to set up big power plants. There is no second thought about it. And this is a trend all over the world, all over the world. Maybe you are not aware that the river Brahmaputra in India, which can be compared to Colorado to some extent, can be compared to Colorado because of the gradient, floods, and all that. The Chinese, we have also built bridges and barrages and all that, but the Chinese are also making power plants on Brahmaputra in their territory. In a way, it's going to affect the flow of water. And what you said in the first question, the Brahmaputra water, Brahmaputra is the river which alongside which a lot of people live, live and do small business and all that. The flow of water in Brahmaputra is going to be affected over a period of time with the construction of these projects in China. And we have taken up with the Chinese government that we need to have our adequate water supply. So, well, that's a different issue. But major power projects are needed at the current time. Yes, sir.
Thank you, sir. So there is a last question in the chat box that what are the various softwares that are available for activity and time management?
Softwares are many of them. One is TIBCO Cloud, accelerates integration by empowering the people in your business. So in the project management, what I have seen that this typical cloud software is mostly used in the project, but all the time innovations are taking place and new softwares are being developed for efficient management of the projects. I mean,
thank you so much for taking all the queries, sir.
The pleasure is
now
mine.
I would like to request our okay, sir.
Sorry to interrupt, sir. I just wanted to thank Dr. Swarup for having a wonderful session, and I hope students learned a lot from you, sir. I just wanted to tell all the participants that it's already nearby 2 a.m. In the United States, where sir is giving us the presentation. So thank you again for having such and sharing such a valuable time for all the participants.
Pleasure is mine, Tagorji. I'm thankful to you. My best regards to your father, Dr. Mohit Mahajanji, and to every one of you. My best of wishes to all the students, and I hope in times to come they find good jobs. That's what I will pray and wish them well in future. Wish them all the best. And anytime you need my help, please feel free to get in touch. It will be a pleasure. Because all through my career, I'm a man of contracts. And all through my career, in the Commerce Ministry in India and overseas, I have dealt with the contracts and dealt with the top brass of the industry in India and overseas. I hope I'm able to make my point. So anytime anybody needs any help, to whatever extent I can, it will be a pleasure. And I'm very happy to see the way the Golden Group of Institutions have grown and the quality of the education and the number of courses which you are conducting is very, very impressive. Raghavji, wish you all the best and congratulations for the good job that you are doing.
Thank you so much, sir.
My pleasure. Goodbye.
Okay, sir. Thank you so much, sir, for having you. Now, I would like to request our dignitary, the principal, Dr. Lakwinder Pal Singh ji, to kindly present the welcome vote of thanks for today's spokesperson. Then we will wrap up our session, sir.
Thank you, Suraj. Very good morning to everyone present over here. It's my pleasure to deliver vote of thanks on a wonderful event webinar on project management. Myself, Dr. Lakwinder Pal Singh, Principal, Golden College of Engineering and Technology, Gurdaspur, on the behalf of Worthy Management, faculty, staff, and students, conveys my heartfelt thanks to today's resource person, Dr. Swaresh Swarup sir, from USA, former Deputy Director, Ministry of Commerce and Industry, Govt of India. Dr. Swarup has nicely detailed about the very emerging topic, that is project management. In short, I say he has told us that the project management refers to the management of all the project activities, resources, and time in such a manner that the best outcome may be achieved. He has also guided us how to use PUT and CPM to achieve the target in a project. Thank you so much, sir, for sparing your valuable time for all of us. I convey my thanks to all the delegates, guests, and participants for attending the event. I express my thanks to the Worthy management and everyone for arranging the webinar and facilities for the event. Along with these few words, I am again thankful to Dr. S. Swarup sir for everyone, for his valuable time and everyone present over here. Thanks. Thanks.
Thank you so much, sir, for concluding the whole session. I, on the behalf of the management of Golden Group of Institutions, thanks to every participant who has maintained the decorum and discipline throughout the session. And this session has already been gone live on Facebook page also. So thank you for having me as your anchor for today's session. We shall hope to conduct multiple webinars in the upcoming future, and we shall request and we should expect the maximum participation for every participant for today's session. Thank you, everyone. Thank you, everyone. We are wrapping up the session. Thanks, everyone.